Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 11, 2025, about 5 days ago. This paper introduces a 12.7 billion parameter reasoning model that matches or even beats much larger 30 to 40 billion parameter systems, with composite scores that edge past the reported results of GPT 5.1 on several reasoning-heavy benchmarks. The paper is titled Motif-2-12.7B Reasoning, a Practitioner's Guide to RL Training Recipes. And, as we will see, the recipe for stable, long context reasoning under tight compute budgets is surprisingly practical. Alright, Figure 1 compares the Artificial Analysis Intelligence Index scores of many leading models on a single composite bar chart, which summarizes 10 tough reasoning benchmarks. The full row of colored bars shows that top proprietary systems cluster around the low 70s, while most strong open models span the 50s and low 60s. The light blue bar near the center, marked Motif-2-12.7B, scores about 45, which is close to much larger models like GPT 5.1 at 43. This placement means the compact model reaches frontier-level reasoning quality despite having far fewer parameters. So, while Figure 1 compared overall reasoning strength across models, Figure 2 focuses on how training data choice shifts coding performance on Live Code Bench version 5. The baseline pass at 1 score is about 52, adding CDOS synthetic data boost that score to about 64, which is a gain of roughly 12 points. In contrast, adding GPT OSS data drags performance down to about 34, a drop of about 18 points that highlights how mismatched synthetic data can seriously hurt reasoning. Alright, while Figure 2 highlighted how data source choice shifts coding scores, Figure 3 lays out how the authors actually build and stage that data. The left pipeline generates diverse queries, produces responses with reasoning traces, then passes them through a strict verification gate that checks consistency, code execution, math correctness, and structure. That filtered pool of aligned data then feeds into the right side, a 3-step curriculum that trains first at 16,000 tokens, then 32,000, and finally 64,000 so long context reasoning stays stable. While Figure 4 zooms into how the data filtering pipeline keeps reinforcement learning training stable by controlling problem difficulty, the left half shows Phase 1, where a raw pool of questions flows through sampling, then a rollout step, where the large language model generates multiple candidate solutions. The right half shows Phase 2, where a scoring block computes each problem's pass rate. Then a diamond-shaped difficulty filter either keeps medium difficulty items as aligned data, or discards too easy or too hard ones. This selective curation ensures the model trains on problems that are challenging enough to teach reasoning without causing collapse. Motif-2-12.7B shows that careful engineering and data curation let a relatively small model reach frontier-level reasoning, even with 64,000 token contexts. The broader message is that stable reinforcement learning, fine-tuning, and verified synthetic data really matter more than raw scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.